Hello, my name is Raymond Doe, and welcome to my Physics 2212 Lab 2 video, Lines of Charge. Hope you enjoy. The purpose of this lab is to compare and contrast the electrical force models of two charge tapes from the perspective of point charges and of line charges. This lab is quite similar to Lab 1, and so it only makes sense that we will use similar fundamental physics concepts, including Newton's second law, the electric field of a point charge, but this time we'll also be implementing the law of superposition and the electric force equation. Before getting into the core of the lab, it's important to establish the assumptions in which we'll be operating under in this experiment. These are that both strips of tape share the same charge, each charged particle is evenly distributed across the tape in the form of a line. These charged particles can all be divided into smaller segments of equal charge, and that air resistance is negligible. In giving you a preview of my results, this is my GlowScript generated simulation of all the forces and fields acting on both tape A and tape B, and below it is an equation derived from Newton's third law of equal and opposite reactions, saying that the gravitational force should equal the electric force. So building off the core concepts of Lab 1, in Lab 1 titled Charged Tapes, we modeled the electric force interactions between these two charged tapes, interpreting the charges of each tape as a point. In this lab, we will be conducting a similar experiment in which we generate the model of the electric force interactions between the charged tapes, but this time we interpret the charges of tape as a line, which can be separated into smaller, evenly charged particles to better estimate the net electric field. Getting into the GlowScript computational code, this slide displays my setup in which I establish my physical constants, initial conditions, and my computational version of the electric field of a point charge. Take note that all of the initial conditions are the same values that we found and calculated in Lab 1. Now encoding the actual simulation that would generate our model and results. Shown from top to bottom is the coding of what was once our point charge representation of the tapes into a line charge representation. Next, you can see the iterative loop that calculates the magnitude and direction of the electric force due to each segment of the line charge and then sums them. And towards the bottom of the slide, you can view the creation of the arrows indicating the force of gravity and the electric force. Here we finally have our visual simulation of the electric interactions between the two tapes as line charges. Below, GlowScript has calculated the electric force to be 1.80982 e to the negative 3 coulombs, and the magnitude of the gravitational force to be 1.81485 e to the negative 3, which is quite good as we should expect the force of gravity and the electric force to be equal or at least close to equal despite our assumptions. Possible errors in this lab may include mistaken inputs and miscalculations in the computational code, along with errors carrying over from Lab 1 such as excessive handling of the tapes and non-evenly distributed charges. This slide simply serves to show the similarities and differences between the models of Lab 1 and Lab 2. When asked what if we had modeled each of our tapes as a single point charge like in the previous lab, we can see the estimated charge of the line charge is roughly twice as large as that as the point charge. Why do these estimates differ? Which value is more likely to be closer to the real value and why? The values are different as it is difficult for a point charge, a single point charge, to give accurate representation for the field of an entire object. The line charge calculation is likely to be the more accurate estimate as it is comprised of several smaller charges, which makes the calculated net charge much more precise than the single point. Thank you for watching and have a great day.